Hello, hello.
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 Have you guys ever organized a workshop and then realized the week before that you only have half a day and not a full day? No! Oh my God.
That's why I never
That's
organize workshops.
that's fun. Let's see.
I think I have the solution already. So we will just move to the meeting room in a hotel that's just next to the venue. So it's like a 5-minute walk.
Sounds good.
Yeah, it's it's fun.
Shit happens. What can you do? Sometimes, right?
Yeah, and I mean it's our fault, of course, but the acceptance email didn't say anything about whether it's a half day or full day, and we submitted a full day, so everyone was like, "Must be a full day then." So, but of course, I mean, cannot say that I'm not to blame for this, or at least the Orga team. But yeah, actually, yeah, I suppose. Yeah.
I think it's fine. I mean, everybody will understand that. Okay, guys, I think we can start.
There we go. Yes,
Hey,
let's get started.
Yeah, let's get started because everybody is in here. Let me share my screen. First topic on the agenda is final design of a compatibility artifact. I came up with this simple document that contains artifact manifest, what kind of media types we have to register, how to discover that, and with compatibility specification. It's very simple. There is everybody can comment and suggest.
And I
Marcin
guess
froze.
Marcin's network dropped.
Oh, is that? I thought that
The
was
track was
me.
going.
Am I still here?
I think he's coming back now.
He's back.
I could hear you all the time and see you all the time. It was just popping up that Vanessa has some problem with network, but okay.
No, I actually have problems with network a lot. I assumed it was my computer just like going off to take a vacation. I was gonna exit and come back, but then I heard Brandon talk and I was like, hold on now, what?
I use "you're walking" as the cue to me that it's
Oh
not
yeah.
a bus, it's Marcin. Go ahead, Marcin, you're back.
Okay, so I will just repeat everything what I said. There's this document with final design of compatibility artifact. Not so many things in there. It's quite simple. It has few sections where like manifest, how we discover the artifact, and the specification itself. I think I kept that simple enough. And if you have any comments or suggestions, you can do this in the document directly. So I would say that maybe we don't have to discuss that right now because maybe people need some time to read that, go through, and we can review this asynchronously and talk on Slack or something, or on the next meeting. So feel free to take a look, feel free to suggest changes and see if you like it or not. Any comments to that? No? If not, then we just move to the second topic. Okay, so the second topic on the agenda is overlap with other communities. There was an interesting discussion on the weekly meeting that we are overlapping, that we might overlap with other communities when it comes to functionality. And I believe we don't, because what DRA does is they are basically on a little bit different scope and context. So what I believe we are doing is quite of unique, because we try to describe compatibility metadata for images. Like it's a different different scope than, for example, dynamic resource allocation for Kubernetes has, and a different scope than node feature discovery. So I feel we are quite okay in here, but I would like to hear your opinions about that. Do you think we are overlapping? We should reach other communities from Kubernetes or somewhere else that we are more exposed, I would say.
I feel like a lot of people are all trying to solve the same issue.
Yeah.
That the biggest issue I see is people are trying to run machine learning AI projects out there, and they're trying to say which machines out there have the GPUs that we can run this on. And
Yeah, that's like
we're
the
all,
one use case, just right there.
we're
Where are
all
the
tackling
GPUs?
it from similar directions. Yeah, go ahead.
Yeah, I
Yes,
definitely
mean,
think there's risk here. I think it depends how deep we go in. So I probably what we want to do is to first start with just the skeleton structures of things. So, you know, we're creating, this is the artifact. We're not saying anything about the labels. And then I think probably what's gonna be much harder to do is when we're actually thinking about those labels and maybe some core set that OCI wants to maintain, we have to kind of do our homework and go look at what the other communities are doing and say, okay, what overlap is here? Is that okay? I think the way that I look at it is that OCI is something that is more sort of, you know, it's going to stand a test of time in the sense that, like, when you compare it to other communities may have labels, but they're going to change much more quickly. I was joking with a colleague the other day that like a year in Kubernetes time or is like 20 years of, and then like any other space. So I think the labels, for example, or that we decide upon are going to be simpler, more so withstand the test of time. Like you couldn't go to another community and be like, let's make these labels a standard, because they're probably going to be entirely different next year. So yes, I do think there's concern about overlap in the sense that like we are all trying to solve like this common problem. Where's the GPU for my machine learning? And I would have that question too, because I always have trouble getting GPUs on any cloud because everyone else is using them, but that's a different thing. But I think as long as we are kind of very careful about that, and we really focus on the use case that we care about, which is, you know, very simply, probably the core one is image selection. I don't think that's an issue. I agree with what Marcin said.
yeah, just a comment to that. I'm also thinking, at least from my point of view, we are not overlapping in a sense that, because what we are doing, we try to provide source of truth for images, some metadata that are very attached to the image. And this can be kind of data source for other orchestrators like Kubernetes. And they have their own sort of mechanism for scheduling, for providing accelerators to pods and so to containers and so on. So we are just filling the gap that exists today, that there is no one source of truth for container images when it comes to these requirements. Because Kubernetes solves that over pods, and the pods definition is very elastic. Users provide their own pod specifications, and it cannot be served as a source of truth for that problem that we are trying to solve in here. So I consider that we are kind of trying to fill the gap, which is quite unique, because we try to provide the subset of metadata for container images that can be consumed later by others. So when it comes to, for example, DRA, they are thinking how to provide this API for resource allocation and so on, but they don't try to, right now at least, describe the same stuff as we do. They don't try to describe requirements for container images. They will just fill the gap by users creating pods definitions, which again is not the unique source of truth for container images. So I'm thinking here that we can cooperate together, but we are not overlapping with them. That's what I think about this.
I think the risk there is if they've gone off and they've built this solution that depends on the user setting up the manifest that they're going to deploy out there, the Kubernetes manifest, and they're not talking to us of how we could potentially integrate this in with the container image, then there's going to be this gap where there's still the user that has to put in the Kubernetes manifest because there's no bridge between the two.
Yes, and Alexander, I don't remember his last name, from Intel on the at the KubeCon meeting, had a good point about that, because he said exactly the same thing as you right now, that there should be some kind of bridge. So what I imagine is that once we come up with the specification, there could be some kind of tool that could generate the specification to pods, node selectors or so to fill this gap. There will be some tool that has to understand OCI labels and later translate this to Kubernetes specific node selectors. And the same for other orchestrators as well. But we agreed under OCI that we don't want to bring a tool that is maintained by OCI, just a standard, right? At least I think we agree on that. And yeah, but the gap would have to be, as always, translated by some additional software that understands both river sides, and then just try to come up with something. Victor, you want to say something?
Yeah, maybe it help to maybe create a collection of landscape of related projects. This is my understanding, like about what you're talking about. This is all way beyond my, a lot of details. But I do go to other places to find related information. My current understanding is DRA is one related project. When it comes to, there's another project, container device interface, which is basically it's the YAML of try to kind of a same YAML infrastructure for different devices. And that's for the infrastructure, but for the application side, the actual AML libraries, they're traditionally, of course, CUDA is the most NVIDIA specific application library. And then the UXL is actually just everybody else, basically, whoever want to participate in that. And so with all that considered, what are they trying to resolve, and is there any overlap? And I think it probably is pretty worth it to build a list of related projects.
Yes, but all projects are very related to their own, how to say that, implementation. Because what we are trying to here, we just try to describe metadata for container images. We don't go into to the CDA, container device interface, and say how exactly those devices has to be connected to containers or so. We just don't care about that. We just provide some metadata, some very small subset of metadata, saying I require this PCI device, or I require this OS configuration, and the way how it's being delivered to container, it's not our business. We just want to provide as abstract metadata as possible that can be used everywhere. That's at least my idea of that.
My understanding is the reason there is such a difference is because of different hardware, different library. That's made the image difference, right? So in the ideal world, if there's only one hardware type, one library, that problem won't exist. Isn't that right?
Yeah, but you still have to express somehow, I need this hardware, I need this device or whatever, right? I mean, even if you have everything unified, you have the same API for GPUs across different vendors, you still might say, I need specific GPU from NVIDIA, or I just need to say, or need to say that you still need a GPU. I think you are very much into implementation itself when it comes to how to deliver all of these APIs to containers and so on. We are just here to say that we require some hardware or configuration. We don't care about these details, how it's brought. We don't care about the API, basically.
I guess I'm not quite. I guess I understand the actual goal of this. If hardware and library is all uniform, what's the problem? I guess I'm still not quite clear. Sorry, Brandon.
Yeah, I think I was going to take your question to the next step, which is, say we have a runtime selection that we're going to do. We're going to have multiple images, some that have a GPU requirement, some that don't. and we run this on a machine that has the GPU that we need. But the definition for the pod doesn't specify that it has access to the GPU. We're still going to select an image that needs a GPU, but it's not going to have access to a GPU. So I feel like there's still this point where there needs to be that extra step that says, yeah, not only do we select this image that needs this resource, but this resource needs to be included as part of the pod or container definition when we spin it up. There needs to be that extra
Wait,
connection.
can you say that one more time? Where would the knowledge about the GPU come in? The person would be requesting? Because if the pod doesn't have like NVIDIA GPU 4 or whatever, then where would the request be coming from?
So say someone deploys this container image to a machine, the definition of what hardware is available to it is coming in from the Kubernetes manifest, correct? So
yeah,
it's
but
gonna
arguably the container, so they're wanting to use a GPU but they forget to, for example, you have the NVIDIA installer that will ensure that the pod actually gets access to the GPU. And so what they essentially are doing is they're pulling a GPU or they're allocating a GPU container to a pod that doesn't have GPU, but then you're saying that the compatibility metadata would still have the GPU, and you would
look at the node. Yeah,
you would need that interface to be like, actually, the node here does not have a GPU.
So it would be that the node has a GPU.
Or sorry.
But
not the node, but the pod doesn't have. But
Yeah.
wouldn't the check be coming from the pod? Like, because
that's a good question, and I don't think we've really addressed that. We've
yeah,
kept
that's
this a
true,
little bit of a higher level.
because most of these devices you can only bind them to like one pod.
But I would say it's not our problem, to be honest. I mean,
yeah,
I'm sorry, I'm maybe quite brutal here, but it's really not our problem. What we are trying to here is just to describe requirements for the images. If it's not our problem if pod spec contains that after the translation, because tool has a specific implementation of the standard, we can give some recommendations, I don't know, for the tooling. But if we have a tool that solves Kubernetes issues and use cases, and there is some mistake in the tool itself that doesn't translate very well those labels we define to the pod specification, I think it's not our problem, because we cannot.
I would lean towards saying let's get some people running runtimes in on that conversation, because everything up to this point has always been, if I'm selecting a container image from a manifest list, I'm just looking at what my overall containerd runtime knows that it can do, what its local platform is. And so to shift that from, no, we're not caring just about what containerd knows about the overall node, but we actually care about the individual container being spun up, that might be something that they weren't ready for. And so we should probably have that conversation sooner rather than later.
Yeah, I think that goes beyond image selection too, because I think it's more scope to you when you're actually doing the scheduling, you need to make sure that, yes, the node has support for the GPU, but also that when the scheduling happens, it will be able to actually get the bind, of the GPU. And then you also have the container with it. I think it's a multi-step complex thing. And I kind of agree with Brandon, or sorry, I agree with Marcin that it's not, we can't solve all problems for all things, but but then I agree with Brandon that we can make sure that we talk to the different communities and figure out how they're thinking about solving that problem and where our particular, labels or whatever we do come into that, and just to make sure that we do the best that we can for that use case. But I do think that it's not up to us to solve every problem with compatibility that exists out in Kubernetes land, because my goodness, there are quite a lot.
Yeah, exactly. And speaking of container, because I think we are here again talking about two different problems. Because when we talk about the container runtimes, you're right, Brandon, they are running containers, and based on the image selection, they have to have this knowledge about that, right? So, but that's why there is this idea you came up with, how to fit containerd with labels and leave the burden on the users in that case, which is fine, and it's a very simple use case in that case, in this. So and it's very specific implementation, right? Because we are trying to solve here containerd image selection. For Podman, it can be completely different, which means we come up with the standard and we try to help containerd and see if they would like to adapt that. But maybe Podman will have something different. This is just my point, that we come up maybe with this platform compatibilities in the index and platform features, but containerd, Podman, other runtimes, it's their own implementation and business to follow that to basically solve the use cases we have. And to maybe go back a little bit to Victor about this hardware unification. If you say, for example, you have one hardware because we have unified everything. Of course, I'm talking about if you have different set of accelerators. You can have GPU, other accelerators, and you have unified everything for different types of accelerators. You still have to somehow express the requirement for the container image that you need this specific accelerator type. So this is what we are doing in here, like describing the requirement that your container image requires this specific accelerator, even if all types of accelerators have the same unified API or so. You still have to somehow describe the requirement.
I think I got half of it. It doesn't really matter it's Kubernetes or not. It's about the containers, and yeah, it seems to be.
Yeah.
Well, in the ideal world, like in the ideal world, there is going to be a unified API, libraries, and hardware. I know it's not going to happen. Just in case it does, what will be in the? So there's no need to specify GPU because the assumption is already hard coded. What will be the most important information included in this image spec then?
So if I understood you correctly, if you have unified API, you will not, in the ideal world, you wouldn't have to. I mean, it's hard for me to imagine your use case, because from this what you are saying, I understand that there will be just one unified API for everything, for every accelerator, and I will lose a requirement to describe for my container image that I need that, which is basically, I think, not achievable, because that would mean every node has to have every type of accelerator included, and then on the container side, you don't have to describe these requirements.
Yeah, there's such a thing. There's an initiative at least called polymorphism, which is basically you have APIs on hardware level, and then so it doesn't matter what kind of GPU, CPU, and there you'll be able to on the library level call based on the. I guess that still need to have input. Yeah, I guess. Let's assume that's true. Let's assume there is just single library, single hardware. Everything is just one vendor. Basically, we just have Intel and NVIDIA. That's all we have. Then what do we need for the image level specs?
I mean, so step by step, if I understand correctly, you have hardware. You have, for example, as you said, NVIDIA GPU, Intel GPU, and you have just one unified.
No, just unified, just one GPU, NVIDIA GPU, Intel CPU. That's the only thing we have. What is still needed for the image specification?
Okay. So for the image specification, imagine you have two containers, images. One requires GPU and one doesn't require GPU. So for the one you require GPU, you say, I require GPU. For other one, you just leave empty. You don't specify anything. We just try to describe this requirement for the container, if it really requires GPU or not. Does that make sense to you?
Yeah.
Because my point is, you cannot have unified. You cannot have all nodes with every accelerator possible, and say on the container side, I don't need anything else.
Okay.
Tomorrow there is a DRA working group meeting, this working group accelerators, I think at least. So I'm going to join this meeting and talk to them about some of the requirements they have to understand better if we really overlap in here or not. My opinion is we don't overlap, but let's see if they have some interesting input. Maybe they would like to take a look into our working group as well. Any more comments? If not, then the final topic. Okay, so the last thing, which is image selection with platform features and platform compatibilities. Prototyping some stuff in here. So because in containerd you have this sorted vector, based on that you make image selection, the first one which is fitting its return. If we add platform features, for example, which is this one, I hope you can see the screen, and platform compatibilities, which is a map string, then we have a problem how to sort this. So I just thought to bring some kind of priorities over platform for platform features and platform compatibility. So algorithm would be something like that. First, you have the standard check, which is OS, architecture, and variant. This is how it works today. There is the match algorithm, which is checking those two things. Later, you check the size of features, and then you check the size of compatibilities. Reasoning behind that. Here is just a CPU with architecture and OS basically. So I mean, this doesn't require a comment. It's quite clear. And later, if we assume that platform features could be for CPUs only, I think it's more important to sort this over than compatibilities, because it can be anything different. Once you apply this algorithm, if you have OS architecture and variant the same, then the sort will be over platform features. As you can see, you have two elements in here and empty compatibilities. Then you have, again, platform features with one element, but it's second because compatibilities elements, the size of the map is bigger than the last. So basically, you just check over this algorithm the best matching for the host. And I was wondering if you have anything, any better idea how we could do this.
I guess my question is, you're designing an algorithm that a tool would use to like order or to find the most compatible, right?
Yeah, I'm just trying to find, not to change the current logic, not to break today's behavior, because you have in containerd the first image that matches out of all that matches in the vector. So once we apply platform features and possibly platform compatibilities, we destroy that, because if you keep random order over those elements, you are not choosing the best fitting one. And that's why I added the size of platform features, how people are specific for the platform features.
Gotcha. The question I'm kind of going toward though is the underlying assumption that this new algorithm is actually in scope of what we need to decide, as opposed to just putting them there and then going to talk to folks that develop these tools and having them as a part of the conversation, or having them kind of lead that conversation.
Yeah, you are right. I mean, we have to talk to containerd folks to judge on that. But before we show something to them, I would like to have some kind of internal consensus with the group that, because there is a small chance that it could be implemented. So once we see this is implemented, we would have a problem later if somebody wants to change that.
Gotcha. So this is using the same level of metadata that you'd find platform on, and it's avoiding the hairball problem that we identified when I was talking to Brandon, where if you have something in like an artifact, you go down this long chain of,
Yeah.
many calls, and then you have like the scoring thing. So
Yeah.
we're basically, yeah, okay, I get it.
So
And does that, sorry, follow-up question. Does that assume that a couple of our pull requests that have been merged that suggest changes to the manifests are adopted for this use case?
yes, I mean, maybe I should start this discussion in a different way. I should start discussion with, what do you think about adding platform features and platform compatibilities into index instead of showing you some algorithms? But
Yeah, because I
yeah.
remember Brandon, I remember there was a discussion point at one point and Brandon said something like, oh no, we're not going to do both of them. So maybe Brandon can comment on what his ideas as a maintainer.
I mean, I was thinking of doing both features and annotations. And so that potentially could go in there, and it does give some interesting complex issues when you have these interfering with each other. This did come up though in the proposal EPR. Joe was asking the same question, and my comment there, I linked it over in the chat and over in the right there. The direction I was going was to say the features is a Boolean, yes or no. And if there are any features, I would just treat that as one tier up. And then from that point, just make it an order. The logic behind that being that you might have two images with two different sets of features that they depend on. One of them might be the really good kernel CPU feature that you really want. And it's just one instruction. Everything goes super quick across that one instruction. The other one might be 3 instructions that you could use as a fallback. The 3 instructions shouldn't take priority over the 1 instruction in that case. So how would you define that? And the only way I could think of was to say, let's just make it based on the order.
Yeah, that's another good point. Couldn't the algorithm that you use also depend on like the specific use case? I'm not sure there's one algorithm. Like when you only had one thing, when you only had platform, like there was one algorithm, like choose the platform, but now there's potentially multiple algorithms. And so the question is like maybe we won't converge on like a single algorithm, but there'll be kind of different algorithms for different use cases.
Yes. Sorry, go ahead, Brandon. You wanted.
I do think that we need to, from the OCI side, say this is the way you make the match and you order them, because otherwise you'll have different runtimes matching different images on the same host.
Oh yeah, getting different containers.
Causes chaos. Yeah.
Chaos.
So we should probably specify an OCI. Here's how we work this out. I think that gets into a question though of which of these are we going to mix and match together, and what does that imply as a result? Because when you start, like you're saying, Vanessa, when we pick just one, it's super easy. You got the one algorithm there, you just pick that one. Once we start adding multiple together, things get a little more complicated. So it maybe before we take that jump into how do we mix and match all these together, we decide which ones we think make the most sense to mix and match together.
Yeah, that makes sense. From my own perspective, platform features, if we limit that to CPU features only, that makes sense. And I like this idea of breaking platform compatibilities with your idea of the duplication, Brandon. That would mean we have subset of artifact provided in the index.
You're saying you want the compatibility and the features together?
Yes, platform features and platform compatibilities together. Features has a priority over platform compatibilities based on the size. If we sort this today with the currently working algorithm, we shouldn't have a problem with some backward compatibility. The only problem I have is that, I don't know, if you limit features, the application of the features, that could work badly as well. You don't want.
If you go by order of the feature, and so you say, look, it's a Boolean, this one match first, we'll go ahead and pick that. If you had multiple feature lists that are identical, and then you could go from that point and say, okay, let me compare these two features are the same. Let me look at now the compatibility after that. I think we're getting into scenarios that are probably significantly more complex than we'll ever see in the real world, but it's good to know what the logic is in case that ever happens.
So just so I understand, when I'm pulling a container, I'm going to have a list of potentially, so minimally, I have no support for this and I still use platform, and that still works. But I might also have a list of CPU features that I say, okay, I want feature A and feature B. And so the new algorithm would go down the list, looking for those two features with the platform that I need. First match, that's it. Like, you don't continue searching to see maybe there's something better. And then the compatibilities only come in. How would the compatibilities come in though, if you hit your first match and then you're done?
It is first match when you can't tell the difference. And so when you can tell the difference, you're allowed to make some priority decisions there. So if, for
Wait, what do you
example,
mean?
if, for example, you've got two entries in the list, one is AMD 64 implicitly V1, and the other is AMD 64 V2. You can match on both of those because you can run on either of those platforms if you're a V3 system. But you're going to prefer the V2 because it's newer. And so you can tell the difference between those two. You're going to pick the newer one, the better one. If you
But
see
why
two
wouldn't you stop
V2s,
at the first one? You say, oh, this one will work. Why would you keep going in the first place?
because we want to find the best match. And so the idea of stopping when you get to the match, the idea of stopping on the first one is only when you can't tell the difference between them. When you're looking at two entries in there and you're saying, these look identical to me, I like them both, I can't tell the difference, you pick the first one. And that's to handle the forward compatibility issues. If someone adds a feature that you don't know how to recognize yet, you don't have the code in your runtime to be able to select between the two, you just always default to the first one.
So that example that you gave, was that a platform or is that a CPU feature that you gave the example of?
Yes.
Which one?
A CPU feature is part of the platform field, so they're all together.
Okay, so for that one, wouldn't you have hit the just matching based on the first platform, that algorithm is out. We're not doing that. So you would hit.
So take a runtime today. A runtime today knows nothing about anything we're talking about right now. And you start putting a bunch of these CPU features in there and other stuff, and it's like, I don't know what the heck any of that is, so I'm just going to ignore it. It's going to see two entries. The first entry is going to win. And so if you throw this multi-platform image at a runtime today, you have a high confidence that it's going to pick a sensible default. Once we start adding this stuff, once we start upgrading the runtimes and it knows how to pick between the two, then it's able to get a little bit more granular in there and say, I know about this stuff. I prefer this one over the other one when I'm comparing these two entries together. And so it's able to pick the better one.
So my question then is the change behaviors that we potentially will be looking at two platforms that are the same and looking at the more detailed features. So we're going to be kind of searching a little bit deeper.
Yeah. So in that case, the platforms aren't the same and the runtime knows how to tell the difference between the two. Because you've added this new features field in there, you've added the compatibility field in there. And so it's got settings that it knows how to tell the difference of.
Okay, but the algorithm is different because it's not just like first match, I'm done, right? I think that's the core of my question.
Yeah,
it's going to very likely.
We had always said that the phrasing we used was first match when you can't tell the difference. And so what we're saying is now you can tell the difference between all these other things we're adding in.
Okay, gotcha. Yeah, that makes sense.
Okay, then I will just continue prototyping that, because I think the artifact idea of platform features, which is limited to CPU with platform compatibilities, which should be deprecated across different images entries, across different manifests, that is a subset, small subset of artifact, makes total sense to me. That works together nicely. And we don't use artifact for the image selection in that case. So at least it clicks with me. I mean,
yeah, the way I'm thinking about artifact, it's for like these niche use cases of like other stuff, research, scheduling. I don't know, like it's not efficient enough to really have as like a core bread and butter part of image selection. Too many redirects and whatnot.
Yeah, I agree with that. Okay, so looks like we are getting somewhere with all of this. Finally.
Marcy's like, finally, I've been waiting forever to make progress in this group. Y'all are so slow.
Yeah, it's okay. I mean, we explore so many different directions, so many discussions. What makes sense, doesn't make sense, but it's not the end yet. We have to convince everybody if it's okay and hear different opinions. Of course, I hope other maintainers as well will join. I added to the channel Derek, Sajay, and Mike. Maybe, what do you think, Brandon, about this idea of reporting to the weekly meeting, that we bring more attention to this? Because I see most of TOB guys or maintainers are there. So if they don't want to come to us, maybe we should come to them.
I am more than happy to give you some time on that meeting, and it's not even me giving you time. You show up and you want to talk about something, we've always got time for folks that want to come and attend. So more than happy to have you show up and give that chat.
Is that like the core maintainer group? What meeting is that?
It's the Thursday developer meeting. It's not a specific maintainer meeting. It is just an OCI general developer meeting, and there happen to be a handful of maintainers that will show up on there. Officially,
Okay.
everything we do is supposed to be GitHub or mailing list, because people can't all hit the same meeting at the same time. But it's a good place to hit a bunch of people.
Yeah, Marcin, if you decide to go 1 week, maybe we can coordinate and I'll go too. I think I used to go to that meeting long ago and far away.
Sure. I plan to attend every Thursday, and just if we have some important update, I will just do the update, or you can do an update as well. So I think just to keep the discussion alive in there.
I figure you want to jump on there and make sure that you're giving your voice, and that's not just me, because I go off in a whole different direction.
No, that's okay. It's totally fine. That we have different understanding and so on. So it's good to get different opinions on that.
Okay, so for this time, we should give feedback on that document that you put out for the artifact.
Yes.
Can you put that, did you put that link in the Slack already?
Yes.
Okay, that's great. Do we have all of the proposals merged? Did we do that?
Yes, finally.
Excellent. Yeah. So I had a bad dream that I missed a meeting, and I woke up and that's when I saw your Slack message. It was like 3 a.m. or something. And I was like, yeah, that's fine, merge it. Let's see. Okay, so that, and it sounds like we're gonna work on this and then the algorithm for image selection next.
Yes.
And then after that, do we want to go back to discussing the label space again?
Yeah, exactly. After, I think we have this design of compatibility artifact and maybe some prototyping around platform features and compatibilities. It's good to have this discussion about the labels, because we will share the labels between platform compatibilities and the artifact spec. So, and I think found some good arguments why we should have our own specification and not use NFT, but we can discuss about that later when it's time.
Sounds good to me. And
You're
Brandon, I
gonna
tried to
leave us on
react.
that cliffhanger?
Sorry again.
You're going to leave us on that cliffhanger? You're not going to tell us the reason? It feels like a setup for like the next week's episode.
No,
or
it's like
something.
that clip
like-
where people take pictures where it looks like you're hanging off into like this, but it's actually like 2 feet off the ground. It's like a fake clipping.
I can tell you. I mean, I was having a very live discussion with Joe about that, because I was a huge fan of using those node feature discovery labels, at least in the form somehow transform under OCI. And when he showed me why he thinks we shouldn't, I mean, basically he was showing me how NFD labels are being generated dynamically and so on, and how much it can grow when it comes to the labels of NFD. We cannot just repeat that. And he basically suggested that we have a small subset of OCI labels basically formatted differently. So, because for example, NFD have OCI kernel module, the name of the module, this is the key, and then you have a value. In our case, we could just have OCI kernel modules a list just to save space and so on. I mean, the point is we cannot take one-to-one what NFD offers today, because it's sometimes too dynamic. It might be hard to predict. And the second thing is it takes too much size if people are starting using that.
So I think you're going down the path though of saying, how do we build the artifact? And you're saying we don't just want to take the full output from the build server of all the features on that node and try to import that and say that's our artifact. Which
kind of yes. My point is we don't take what NFD provides. We don't put this into artifact that we have easy translation or something else. My point is we just come with they have a good categorization of labels that we can be suggested by, which is good to consider. But the label structure itself and the things they provide there, and they have there as well their own unique way of discovering stuff on the node. So my point is we can follow the categorization from NFD somehow, the general abstraction, but the labels we could be a little bit better.
Because I think the path I'm going is I want to keep a big gap between these are all the features, whatever we've discovered on the node that we ran the build on. And these are the features we actually require to run this image. Because the build node is going to have everything, but we don't need to have the same server we use to build the image to run the image.
Yeah. Yes. If I understood correctly, then yes.
And I'm just worried that people might get a little too attached to, okay, NFD does it all. Let's just grab the full output of that and dump that in and say that's our artifact. And I want to be able to say, hands up, wait, no, stop, that's bad, because that creates a scenario that will be a very bad user experience.
Exactly.
Overfitting. Dun 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 dun. Sorry.
This is what I want to avoid as well, right? We don't follow this path because that's a bad idea. I also in the past thought about convincing NFD guys to move their labels constructions or the labels itself under OCI, but I'm pretty sure they wouldn't like that because they as you said in the past, Brandon, that we come up with the standard, not them. And the second thing is they wouldn't like that because it would be too slow for them. They would be every change under OCI is much slower than NFD, their small project. Oh, sorry, not small project, NFD guys, if you're watching that, the project is big.
They're probably not going to watch it.
I want to circle back to your original concern though, because you're saying, hey, it's too fine grained, it's too much data coming out of NFD, all this. Is that still a concern if we're not taking the output of a full NFD scan, but we're just saying, here are the 2 or 3 labels that we know are important to run this image?
Yeah.
Is that still a reason that we would say we don't want to use NFD directly?
When you say use NFD, do you mean take one of their labels and include it, or do you mean use their, their tool to extract a particular metadata attribute?
I'm thinking take their label. And so for someone that's building an image to say, look, when I'm building this image, I want to build a variant of this image that needs this one GPU, this one, whatever hardware device it is. Here's the label I'm injecting as part of my build. That then gets put into the compatibility of that image that gets generated. And then everybody that's using it doesn't have to do a mapping. They can just use it as is.
My question is, what happens if that label changes? What do we do when the NFD label changes?
Yes.
Like arguably, if it's not under our control, that's always something that could happen. Or not the label. What do we do if the potential values that the label can have changes?
That's a good concern. I mean, to answer first Brandon's question, I don't have an answer for that right now. I will have to think more about that. But the highest two are the most important arguments today, not to use NFD, is the size of the index, because they are in their construction of labels they are too granular, right? The construction of the key with the feature that it represents takes too much. And the second thing I thought, but I forgot. So yeah, basically what Vanessa says, right? this is the another concern as well, that what we do if something changes in there. So we cannot just follow blindly NFD. We have to come up with our own categorization and labels. And I thought in the past about this categorization, at least, that we come up with CPU stuff, features, model, PCI, USB, and kernel stuff. However, the structure should be different. We shouldn't create these labels dynamically, like you have kernel modules dot name, which is a key. It should be kernel modules list of them. But this is just my thoughts right now. Probably it's gonna change as well in the future, because I'm hardly thinking on that. It gives me a hard time. So let's see where we will land with that.
Yeah, one thing I'm interested in, and I don't know the best way to do this is, like, let's say that we come up with a set of these contender labels, right? My interest is like, what is the added value of each of the labels that we've designed? So for example, let's say there's one in there about GPUs. That's going to be like a high value label in the sense that, like, it's probably going to be useful in many different use cases. But what if we have labels that go in that, you know, are not high value, whatever that happens to mean? So I'm thinking down the line, at least from someone that usually does kind of experiments or research to kind of understand these things, like how we will be able to assess that. And then will there be a process? So like, okay, let's say we design a label and it's kind of useless, right? Is it just going to stay there forever? Or are we going to have a process for the label graveyard like they have for Ben and Jerry's ice cream flavors? Like this is, and also what happens when the landscape changes? What's the process for adding a new label, for removing a label? So I think that we're going to actually have to be talking more than just like, these are the labels, but what is the life cycle of labels? How do we make, when do we make these decisions? How do we make these decisions? What's the protocol for that?
Yeah, we would have to come up with something, but I like the name.
Yeah.
But the labels graveyard, it's a good name.
Bring back Google Reader. Why did they do that to me?
So the thing how I think about that right now, that we should come up with some kind of abstracted way. Like for example, you don't have to come up with, like, let's say GPU label, but you can come up with PCI, class, vendor, and ID that describes already GPU stuff. So we can be as abstract as possible and bring some very important labels, like what it means for me to the importance, like CPU, PCI, USB, kernel, OS, like MPI stuff maybe, and so on. So but I get your point, Vanessa, that we should come up with these processes, and we would have to discuss that. We would have to also probably, the most important opinion on that would be from TOB. I think how do we handle this kind of stuff, if they like to handle
Did you
this.
just look at Brandon? I
Yeah.
saw you glance. Yeah.
Because all of this means we need to have new maintainers for the standard.
Yep, we got to get maintainers to maintain it, and you know, they'll be able to stick around not just for on the 1.0 release, but there and still voting on the 1.1 release later on, because we've had that problem before.
Yep. So yeah, I already told that, but I can, if there is requirement and if there is agreement, I could be a maintainer.
I think before we get too far into creating a new spec and getting maintainers and all that, it's probably best for us to work down the process of getting some implementations. So I know, Marcin, you've been working on a bunch of that on the Containerd side. I need to do some of that, I think, on my own, you know, prioritizing annotations, that kind of stuff. And then we need to start talking to those other groups and saying, hey, if we were to do this or that or the other, what are your thoughts? Would you be willing to accept it? Is this a flat out reject? Are there changes you'd like to see? And start working down that path before we work the TOB path.
Okay. I'm going to join Kubernetes related working groups, DRA, NFD, all of this stuff, discuss with them, and I will bring those guys in here or give you feedback of what they think and so on. When it comes to this containerd, I clone containerd into OCI Playground, so I will publish my branch soon or so. Let's see how this is gonna go. And Vanessa also had this idea of hackathon, so we can think of that as well if there is interest in the group. So
Yeah, I'd love to do a hackathon.
okay, guys. I think that's all for today, unless anybody has anything else. Okay, that was very productive. Thank you for joining, and talk to you soon.
Yeah, have a good rest of your Monday, folks.
Bye bye.
Cheers.
Bye.